This week, we continue our study of probability distributions, and we've talked about discrete, which are distributions that take on just specific numbers. So if you think about rolling a die, it could be a one, a two, et cetera, all the way up to a six. That's a discrete distribution. And then we have continuous distributions, which can take on an infinite number of values. And last week we looked at the normal distribution, which is an example of one of those. We're going to look at two more distributions here that are both continuous. And we're going to first talk about the continuous uniform probability distribution. So if you think about a random number generator, and if we put in a zero for our minimum and a one for our maximum, we could have an infinite number of numbers generated that are between zero and one, just depending upon how many decimal spaces we went out to. So if we think about this as the distribution of this random variable of a random number generator that went from zero out to one, that would be our distribution. And if we were using a fair random number generator, every single number between zero and one would have an equal chance of occurring. And so this would be a straight line, a straight horizontal line going from zero to one, and that would be our distribution. And because all of these probabilities are the same, that's where the uniform distribution comes in. And if we think about probability, we know that the distribution has to sum to one. So we know the area under this is one. And so our height here to make this one is going to have to be equal to one. And we'll look at a formula for that in a minute. And we know every value in there is equally likely. And because of that, we can calculate some probability. So if we know this whole thing is 1 or 100%, for example, if I looked at the value of a half to 1, what's the probability that I get a number between 1/2 and 1? Well, I think that would make sense to you that half of this would be 50% or a half. So that's what a uniform probability or continuous uniform probability distribution is. Let's look at some of the properties of it. So when we have a uniform distribution, this is the notation that we use for it, and we write that as capital X, which always stands for a random variable. The tilde sign means distributed, and the capital U means uniformly. And then we state the interval from the minimum to the maximum. The function itself is given by the formula 1 over the max minus the min. So in our case, for the random number generator, remember this is 0 and 1, and up here we would have 1 over 1 minus 0, which is just equal to 1, and we knew this was a line for our case at y equals, or f of x equals 1. But the generic formula is just this 1 over b minus a. That will give you the height of the density function. Just like we had mean and standard deviation of other random variables, we can do that here as well. So the expected value or long run average of a continuous uniform probability distribution is just the min plus the max divided by 2. So if we think about our random number generator, 1 plus 0 is 1, divided by 2 is a half, and that would make a lot of sense in this case, that the average value is a half. It's right in the middle of it. So that's where this equation comes from. The standard deviation is a bit more complex. We'd want some calculus to get into that, but I'm not going to do that here. Just know that the formula is the square root of the max minus the min squared divided by 12. Let's look at an example. I have a random variable that's the amount of time in minutes that a person wastes for a bus, and we're told that it's uniformly distributed between 0 and 15 minutes inclusive. We're asked to find A and B and describe what they represent. Well, A is always the minimum value, which in this case is our 0 here, and we're talking about minutes. And the interpretation of that would be that this is the minimum wait time. The B is the maximum value, in this case 15 minutes, and that is going to be the maximum wait time. Let's draw a graph of it, and then we'll write out the distribution. Well, we know the minimum's 0. We know the maximum here is 15. And we know it has a straight line that runs across like that. And the question is, what is the height of this, or what does our f of x equal? Well, we know in general that f of x is equal to 1 over b minus a, or in this case, that's going to be 1 over 15 minus 0, or just 1 over 15. What it means is that is the height of this line. This value where that horizontal line crosses the y-axis is 1 over 15. All right, let's write it out. We know that x, the random variable x, is distributed uniformly across the interval from 0 to 15. So if you're asked to write the distribution, this is what that looks like. Let's talk about the mean and standard deviation. Well, the mean, mu sub x, is equal to a plus b over 2, which in this case is 0 plus 15 over 2, which is equal to 7.5. And our label here would be minutes. Our standard deviation is going to be equal to the square root of the b minus a squared over 12, which is going to be the square root of 15 minus 0 is 15 squared over 12. And if we put that into the calculator, that's approximately 4.33 minutes. All right, let's interpret those now. And remember, these are probability is a long run average. So the 7.5 is over a long period of time. We could expect to wait on average 7.5 minutes for this bus. And that typically varies by about 4.33 minutes. All right, let's stop for a knowledge check.